Okay, so let's take a look at efficiency. Okay, so here we're going to use the analogy of rowing a boat, right? So we have a, if you watch those kind of Olympics or games and stuff like that, where you have like the boats that you have to row the boat, have a team of 4 or 6 people, and they each have one paddle there that they want to do it, right? And they're doing at their own pace. So then, and you have a distance that these people have to do, and they have to be as fast as they can, right? So that means that everybody have to row in exactly the same pace, right? So what will happen if someone don't row at or paddle at exactly the same pace as the others? Well, then if one is faster than all the others, the boat is going to go to a side, and then you're spending a lot of energy, but you're not covering as much distance. So you have to make sure that everybody is paddling at the same pace, because if you don't, you're going to spend a lot more money, you're going to spend more effort, more energy to do less, right? And that's kind of a key concept here. We want every process to be paddling at the same pace. And if one of the production processes is faster than the other one, we looked at theory of constraints, you'll either generate too much inventory or you're going to spend a lot of money. So think about our capacity calculations there, right? If you have someone that's being used 40% of the time and another person 100% of the time, the 60% of the time of the first person is just a waste of time. It's a waste of money. And the same thing for equipment. If you buy an equipment that is very, very good and it's amazing and it's productivity is huge, but you don't need that much, you spend too much money. So that is a waste of money. That's a cost that I don't need. So we want everybody to produce at the same pace. So how do they do that? Into rowing, paddling, or you can think about those kind of ancient Greek films like Spartacus, or maybe the newer one will be Troy for you guys to remember. That's because it has Brad Pitt and what is the other name? I don't know, remember the other guy. And so you remember that there is kind of the boats that everybody's also having to paddle, and and they have to make sure that everybody is in the same pace, or they will hit in the other one. So how do they do that? How do they make sure that everybody's in the same pace? Well, they do that by having a pace, right? A pace that dictates what everybody should be doing, right? Or the rhythm of what everybody should be doing. And that's called takt time. And takt time is the only word in Lean system that's not Japanese. That actually the Toyota took from a German automaker, and because they had that to control the pace of the line, right? So takt is actually a German. And the takt time is the pace of the customer. So that's the idea. Well, okay, so every process should be the same pace. What should be that pace? Oh, should be the quicker one. Well, no, because if you produce a lot and the customer doesn't want a lot, then you have a lot of waste. So that's the difference between the theory of constraints and lean, because lean will tell you that you should produce in the pace of the customer, okay, not in the pace of the fastest process or the slowest process. So even if your processes are faster than your customer, you should slow them down, because if you produce more than the customer, you have a lot of inventory there and a lot of waste associated with that, because you have to put it there somewhere, have warehouses, and all different kinds of problems that too much inventory can cause to you, and costs associated with that. So takt time is the pace of the customer, and that dictates the pace of the whole production process. Everybody should be producing according to takt time. How do I calculate that? Is the total available time to produce divided by the amount of products that need to be produced, right? So thinking about our example here, remember we had the sheet of paper somewhere here that had the days of the week and blah, 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 the days of the month. And this is what we're doing here, right? So we have 2 times 8 hours per shift, per day, sorry, 2 10-minute breaks per shift. So 8 times 60 minus 20 is 460 minutes or 27,600 seconds. And my demand per shift is 920 because it's demand per day, divided by 2. So I know it's a magic number that only happens in textbook examples. 27,000 divided by 460, or 460 divided by 460, that's 1 minute or 60 seconds. Basically saying that every 60 seconds, the customer will demand a part. That's the pace that you have to produce. So your processes have to be designed not to produce one every 30 seconds, to produce one every 60 seconds. Not one every 120 seconds. Well, not even one every 60 seconds. A little bit quicker than that because you want to kind of cope with some kind of variation that will occur during the production process. So, but that's the takt time. Takt time is a very important concept because that's the, what do you call it, maestro of the symphony, right? You have the symphony orchestra, you have the maestro there, and he's dictating the pace that everything have to work. So think about everything work as a clock, right? That you have the, everything have to be perfectly arranged. The same thing in the symphony. Every the pace have to be perfectly arranged, and that pace is takt time, a very, 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 very important concept in lean systems.